In this video, we are going to discuss unsupervised algorithms we need for segmentation. In general, there are three algorithms we need to know for this purpose. Two unsupervised algorithms, hierarchical clustering and k-means clustering, and one supervised one, decision tree. Let's start with hierarchical clustering algorithm. In clustering, everything is based on some distance. There are different methods of calculating distance between 2 points of data. If you would like to know a bit more about distances, you can check it by clicking on the link above. For simplicity, we will assume that our data points are in the two-dimensional space, and the distance is a regular Euclidean distance between the points. So, hierarchical clustering works the following way. Here we have data points, and each data point is treated as a separate cluster. Then, two clusters with the minimal distance are merged into one cluster. Then, the next two nearest clusters are merged together, and so on until one big cluster is formed. As you can notice on the right, while we were merging the clusters, we were also drawing a dendrogram mirroring this process. It shows the hierarchical relationship between the clusters. After a dendrogram is formed, you can split it into the number of clusters you need. Now, let's look at the k-means algorithm. The algorithm is based on the distances between the data points too, but has a different methodology. Firstly, you should decide the number of clusters you want to see. Let it be 3 for our example. Then each data point is randomly assigned to one of these 3 clusters. And centroids, arithmetic mean position of all the points in the cluster, are computed for each of these clusters. After centroids are computed, each data point is reassigned to the cluster with the nearest centroid, and centroids are computed again based on the new formation of clusters. The iterations with centroid calculation and reassignment are performed again and again until clusters no longer change. Now let's compare advantages and disadvantages of these two clustering algorithms. K-means has the following advantages. Quite often it is computationally faster than hierarchical clustering if the number of clusters is small. Another benefit is that it easily adapts to new data. Meanwhile, for hierarchical clustering, you don't need to choose any parameters in advance, and dendrogram is visual and very easy to interpret. Each of the methods also has some disadvantages. For k-means, it is difficult to choose the appropriate number of clusters. Moreover, it has troubles with clustering data of varying size and density. Hierarchical clustering has low stability, so it can produce completely different results with slightly different samples. This algorithm is also sensitive to outliers.